So here we go. Some of you may not need to watch this video, but for those of you that do, I do hope it's helpful. I think of dimensional analysis or factor label method as going on a trip, and we're going to pack our bags with conversion factors as we need them. So as I said, dimensional analysis, sometimes known as factor label method, sometimes written as FLM. We want to try to use the unit labels to help us solve the problem. So let's start in a really simple way. Pause the video or at least think about this problem. If I had $1.85, how many pennies would I have? Of course, you think that's an incredibly simple problem. In your head, you know that's 185 pennies. You had no problem solving that, but what you actually did was multiply $1.85 times 100 pennies per $1. Then the dollars would cancel out, resulting in 185 pennies. Nobody does this, of course, but the units can certainly help you solve a problem that's more challenging. For instance, let's take a look at this. If it takes me 3/4 of an hour to get to school and the distance is 8.5 miles from my home, calculate my average speed in inches per second. So we need to first think about what is the question. Let's highlight that. Certainly not hard. You can see you're being told to calculate the speed, obviously it's an average speed, in inches per second, which of course also gives you the units, inches per second. That is to say, we are trying to find out some speed, some number in inches, some number of inches per every 1 second. So, as we think about a place to start this trip, we want to start with something that has similar units in the numerator or the denominator, meaning we want to start with some kind of length up top and or some kind of time down below. And then we'll go after any conversion factors that you'd either be expected to know or we could Google to look up. Those might be something like this. You know that there's 60 minutes in 1 hour. And since this 60 minutes equals 1 hour, that allows you to write it as 60 minutes per 1 hour or 1 hour per 60 minutes. Anytime you have an equality, you can write that equality right side up or upside down to use it as a conversion factor. Let's go back to the problem. So I've put the conversion factors here that we may need, and as we already said, we're trying to find inches per second. This is where we want to land when the trip is over. We want some number of inches per 1 second. So we'd like to start the problem with a length and a time. So as I go up above, I can see the length is 8.5 miles, and I'm told in the problem that's per 3/4 of an hour. So I'm wanting to start this problem as miles per hour. I can travel 8.5 in 0.75 of an hour. So if we would like to solve and get in inches per second, we want to do this as one problem with one equal sign. So we've got to get hours to cancel out and miles to cancel out so we can end up with inches in seconds. It doesn't matter because all of this will be multiply. It doesn't matter what order you throw down these conversion factors. Any order will do, but I'm going to let these units help me. So let's get rid of miles. So if I go up above, I could see I could use 1 mile per 5,280 feet or 5,280 feet per 1 mile. How do I know which one to bring down below? I need miles to cancel out. So I'm going to choose this. Let's write it in. 5,280 feet per 1 mile. That will allow miles to cancel. And then we'd have, if we stopped right now, we'd have feet per hour, not where we want to end up. So we've got to do something with the feet. Well, we know what that is, and we want feet to cancel out. So we're going to choose the conversion factor where feet is down below. So we might do something like 12 inches per every 1 foot, which will allow us to cancel feet out. And now we're getting close. We're trying to find how many inches, and right now I've got inches up top, but I've still got hours down below, so we need to do some time conversions. So let's find a conversion with hour in it. And since hour is in the downstairs in the denominator, I need to choose the conversion factor with hours up above. So I'll go back to blue again and say there's 1 hour in 60 minutes, so that hours will cancel out. And that would, if we were to stop right now, that would give us inches per minute. We're close, but of course we need the conversion to finish and know that 1 minute contains 60 seconds. And so now minutes will cancel out. And since the only units left standing are inches per second, if we do the math on this string of multiplying and dividing, we'll end up with a value that will tell me my speed in inches per second. Obviously, we're not going to do any dividing by 1. We're not going to need to multiply by 1s because you certainly know that's not going to change the value. So break out your calculator, and anything that's in the denominator, just push divide. Don't write down any intermediate values. Don't calculate and stop or use parentheses. Just take 8.5, push divide, push in 0.75, then hit multiply, 5280, then hit multiply by 12, then push divide by 60 because it's in the denominator, and divide by 60 again, and lo and behold, you can end up, I believe this number will be 199 inches per second. Let's try one more. This is quite a silly problem, and so you might want to consider pausing the video to take time to read this problem and think about where we want to start and where we want to finish. So see if you can read and find the question first, and then come up with some conversion factors once you know the question and you know the units on your finish. Pause and at least get the start and the finish. Okay, hopefully you realize we're wondering how much money does she have in her pocket. So when we're done, we simply want to know dollars. How many dollars does Betty Lou have? All right, you might consider starting this problem with either the fact that Betty Lou has 60 goats or the fact that $55 is 100 pounds of hogs. For instance, we might write down 60 goats, or we might start with Betty Lou will end up with $55 for 100 pounds. That's, of course, 100 pounds of hogs, not 100 pounds of goats. So if we're going to get from goats to money, or we're going to get from money, but money for these, this is, of course, for hogs, then we need to use some of the conversion factors. We can see that 5 goats equals 7 sheep. We can see that 4 sheep equals 2 hogs, and those hogs weigh 250 pounds each. So if we started with goats, we might next want to put in a conversion factor such as 5 goats down below and 7 sheep up top. That way we know that goats will cancel out. But we don't know what kind of money we get for sheep, so Betty Lou needs to trade her sheep in for hogs. 4 sheep, I know, a little bit silly, for every 2 hogs. But we need to then worry about the weight of those hogs. So 1 hog, that's a 1, weighs 250 pounds. Now we're finally ready to use the $55. $55 per 100 pounds. Notice that the sheep canceled out, the hogs cancel out, and the pounds cancel out. The only unit left standing would be 55. Just as easily, we could have started with the $55 because we know we want to end up with $1, so let's start with $1 up above. This gets a little confusing now when it's pound per hogs, but we just needed to keep clear about that it's hogs, not pounds of sheep or goats. So we would need to say that 250 pounds for every 1 hog. Again, we're not worrying about this particular unit. That will allow us to get rid of pounds. But we need to know how much hogs came from sheep, so we can say that for every 2 hogs or pigs, Betty Lou's got to trade 4 sheep. And Betty Lou, of course, started with goats, so for every 7 sheep, Betty Lou trades 5 goats, and Betty Lou started with 60 goats. So the previous one may have felt more comfortable. Either way, we can get there. Our hogs will cancel. The sheep will cancel, Betty Lou's original 60 goats will cancel, and all that's left standing is the dollars. Once again, when you do the math, just punch it all in at once. 60 times 7 divide by 5. Anything in the denominator, times 2 divide by 4, times 250, we certainly don't need to do anything with that one, times 55. And lo and behold, you'll get there. Betty Lou's expecting to make almost $6,000. So go ahead now and get practicing.